let's solve these two problems of electrostatics. The first problem says a charge small q is placed at exactly a corner of a Gaussian cube. Calculate the total electric flux passing through the cube. So in this diagram, suppose this is the charge small q present at a corner of the cube, and we have to find the total electric flux coming from this cube. So here the total charge is present small q, but what is the contribution of this charge small cube inside this cube? So if you make 4 other cubes like this, suppose you make it like this, we can make. So this is another cube, and in front also you can make 2 more cubes like this. So this charge small q is being shared by all these 4 cubes, but above these 4 cubes also you can make 4 other cubes, right? Like this, and similarly here also. And one last one. Yeah. So now this small q charge that is present at the very center of these 8 cubes we have drawn. So these 8 cubes are sharing this total charge small q. So q charge is being shared by 8 cubes. So we will write the charge enclosed inside the cube. So in the original diagram, how much charge is enclosed by the original cube? This one cube it will be. So because the total charge small q is being shared by 8 cubes, so one cube will share only 1 by 8 of the total charge. So 1 by 8 q is the charge enclosed inside this cube. And if you use the Gauss law now, Gauss law says that if the total enclosed charge by a surface is small q, the total electric flux coming from that closed surface will be q divided by epsilon naught. So here total enclosed charge by the cube given in the question, that is 1 by 8 q, and that divided by epsilon naught. So the answer will be q divided by 8 epsilon naught. That is the electric flux coming from the cube which was given in the question. So this was question number 1. Now let's come to the question number 2. Question number 2 says an insulating sphere carries a total charge that is distributed uniformly throughout its volume. It is found that electric field at a distance of r1 and r2, which is greater than r1, from the center of the sphere are equal in magnitude. Find the radius of the sphere. So in this diagram we have 2 points P and Q. Point P is inside the sphere and Q is outside the sphere, and distance of point P and Q from the center of the spheres are r1 and r2 respectively. And the total charge, suppose that is total charge is capital Q, that is uniformly distributed inside the volume of this total sphere, right? So it says that electric field magnitude at points P and Q are same. So we suppose the electric fields at these 2 points are E1 and E2, then E1 is equal to E2. It is given in the question. Now for a uniformly charged insulating spherical charge conductor, the electric field at internal point, that is given by the formula 1 upon 4 pi epsilon naught q total charge multiplied by small x, or here you will write the distance from the center, that is r1, and divided by radius cube of the sphere, so radius r. So if it would have been a charged conductor, then all the charge would have been on the surface only, and any point inside the sphere the electric field would have been 0. But it is an insulating sphere and charge is present in the whole volume. So electric field inside the sphere, that is not 0, that is given by this formula 1 upon 4 pi epsilon naught q into distance of the point from the center of the sphere divided by cube of the radius. So this is for internal point. And for external point, this whole spherical charge will behave like a point charge kept at the center of the sphere. So it will be simply Coulomb's law, and you will write the electric field at point Q due to the whole sphere, that will be simply point charge formula 1 upon 4 pi epsilon naught capital Q divided by r2 square, right? So from here we get 1 upon 4 pi epsilon naught cancelled, and capital Q is also cancelled. So from here you have r1 divided by r cube, that is equal to 1 upon r2 square, and from here we can write r cube is equal to r1 r2 square, and after this we can write r is equal to, that will be cube root of all this, so it will be cube root of r1 r2 square, or you can write r1 to the power 1 by 3 and r2 to the power 2 by 3. So this will be the radius of the sphere which was asked in the question. So this is your answer to second question, and this is your answer to the first question. So I hope you understood this problem and how did we solve these two problems.